Welcome back. What we have seen as a consequence of the basic statement of first law is this integral must represent change in some property. Now the question is, which property is this? We define this property to be the thermodynamic energy, or simply energy E of the system. And the formal definition would be, notice that it represents change in some property. So we would be defining in a differential format, the differential of energy is minus the differential of adiabatic work, and in the integral format, the difference in energy delta E12, which will be defined as energy of the final state minus energy of the initial state. This will be defined as minus integral 1 to 2 dW adiabatic. The first law says that since it is adiabatic, we do not have to worry about the path. For evaluating this integral, we execute any convenient process which is adiabatic and which starts from the initial condition 1 and ends at the final condition 2. Now, one thing we will notice is that we have used a negative sign. This negative sign is a matter of convention. We have come across one convention already. That was the convention for work interaction. We said that let us consider the work done by the system to be positive. Here we put a negative sign so that whenever a system does work, that means when the right hand side integral is positive, the left hand side the change in energy would be negative. And this is just to be consistent with our personal feeling that when we do work, we feel exhausted, our energy levels go down. But remember that it is a matter of convention. There is no thermodynamic principle involved with it. Okay. Now, one thing which we should note is the following. We should note that is defined using its differential dE or its difference delta E. This means only differences in energy between two states of a thermodynamic system are significant, and this automatically implies that actual values are meaningless, are either meaningless, or we can replace this are not meaningful, because we will never really use absolute values. We will always be using differences in energy or differentials of energy. Thank you.